how much pure alcohol has to be added to 400 ml of a solution containing 15% alcohol to change the concentration of alcohol in the mixture to 32%. It is given that this 400 ml of solution contains 15% alcohol. Therefore, we can calculate the quantity of alcohol in this solution. It is equal to 15% of this solution. So 15 upon 100 times 400. And that is equal to 4 times 15 is 60. So 60 ml of alcohol is there in 400 ml of this solution. Now I have to increase the concentration of alcohol in the mixture to 32%, and to do that I'll have to add some pure alcohol to this solution. And if I add some pure alcohol, let's say I add X milliliters of alcohol in this solution, the solution's volume will also increase by X milliliter. Now the required percentage is 32%. So if I take the new percentage of alcohol over this solution, I'll get 32%. So I can write 60 plus X alcohol out of 400 plus X milliliters. If I take the percentage, I should get 32. So we have to find out how much amount of alcohol must be added. So this can be simplified now. Let's multiply 100 here. So 6000 plus 100x is equals to 400 times 32. 32 times 4 is 128, and we have these two zeros, so 12800 plus 32x. So we have 100x minus 32x is equals to 12,800 minus 6,000. So 100 minus 32x is 68x, and this is equal to 6,800. So therefore x is equals to 6,800 by 68. This gets cancelled out and what remains is 100. So therefore x is equals to 100. So we must add 100 ml of alcohol to this solution in order to make the concentration to 32% of alcohol. Milk contains 5% water. What quantity of pure milk should be added to 10 liters of milk to reduce this percentage to 2% of water? Well, it is given that milk contains 5% of water. So we can calculate how much water is there in 10 liters of milk. So water in 10 liters of milk is equals to 5% of it. So 5 upon 100 times 10. And that is equals to 0.5 liters of water. Now we have been given the required percentage of water in milk, which is 2%. So let's write that expression. The required percentage of water in milk is 2%. So water upon the complete solution, so total volume times 100 to calculate the percentage, is equal to this 2%. Now this 2% will come only when we add some more pure milk to this complete solution, because if we add milk, the percentage of water will be reduced. So if we add milk, we won't have to add anything to water, right? The water in 10 liters will be as it is, so it will be 0.5 upon the total volume will be increased by the amount of milk that we add. So the total volume is currently 10 liters plus some more amount of milk that we will add times 100, and the percentage should be 2%. Now we have 0.5 into 100 is 50 is equal to 2 times 10 plus x, so 20 plus 2x. Therefore x is equals to 50 minus 20, that is 30 by 2, which is 15 liters. So therefore we should add 15 liters of milk in order to reduce the percentage of water to this 2%. One type of liquid contains 20% water and the second type of liquid contains 35% of water. A glass is filled with 10 parts of the first liquid and 4 parts of the second liquid. the percentage of water in the new mixture in the glass is? Well, if you have to calculate the percentage of water, we can write it as the total water upon the total volume of the mixture times 100 will give you the required percentage. Now, to calculate the total water, we will have to analyze our question. Now, it is given that the glass is filled with 10 parts and 4 parts of the given liquids. And of the first liquid, 20% is water, and of the second liquid, 35% is water. So we'll have to add water contained in first liquid and water contained in the second liquid. So the water contained in the first liquid is 20% of that liquid. So 20 upon 100 times the volume of that liquid, and it is 10. So 10 plus the water contained in the second liquid is 35% of its volume, and its volume is 4 parts. So times 4 divided by, we have the total volume. We have the total volume, and the total volume is 10 plus 4. We have to add the volumes of these two liquids. So 10 plus 4 and times 100 to calculate the percentage. So this is equivalent to, we can cancel out terms here. So these zeros get cancelled out. So I have 2 plus 35 times 4 upon 100. So 4 times 1 is 4. 4 times 25 is 100. So I have 35 by 25 upon 10 plus 4 is 14 times 100. So this is, again, it can be simplified to, I can again cancel out terms here. 5 7s are 35, 5 5s are 25. So 5 times 2 plus 7. So 10 plus 7, which is 17. By this 5 comes down, so 14 times 5 times 100. So 5 times 20 is 100. And again, I can cancel out terms. 2 times 10 is 20, 2 times 7 is 14. So this is equivalent to 170 by 7. Let's divide 170 by 7. 7 2s are 14. 30 is the remainder. 7 4s are 28. So 2. So this is equivalent to 24 2 by 7%. And that's what we have, the answer. Option B. In some quantity of ghee, 60% is pure ghee and 40% is vanaspati. If 10 kg of pure ghee is added, then the strength of vanaspati ghee becomes 20%. The original quantity was. Let us consider this original quantity of the mixture be X. Now, from the data that is given to us, it is said that 40% of the original quantity is vanaspati ghee. So I can say that amount of vanaspati ghee is equals to 40% of X. So 40 upon 100 X. Now they are adding 10 kg of pure ghee to it. Of course, we are not adding any vanaspati ghee, so the amount of vanaspati remains the same. Only its relative percentage gets changed. So I can write, after adding pure ghee of 10 kgs to the mixture, the amount of vanaspati is equal to 20% of the quantity, of the total quantity. So 20 upon 100 times the total quantity, which is X, plus, as we are adding 10 kg pure ghee, the total quantity will also be increased by 10 kg. So X plus 10. Now we have the amounts of vanaspati as same, so I can equate these two equations. So I can write 40 upon 100 X is equals to 20 upon 100 times X plus 10. This 100 and this 100 gets cancelled out. This 20 times 2 is 40. So 2x is equals to X plus 10. So 2x minus X, which is X, is equal to 10. So the original quantity was 10 kgs.